There's a song that's inside of my soul. It's the one that I've tried to write over and over again. I'm awake in the infinite cold.
There are a lot of stars.
You're right.
Shan, the moon is probably the only star you can normally see, right?
The moon doesn't count as a star.
Why not? The moon is so bright. Why is that considered as a star?
The moon's only reflecting the sun's light. Besides, stars can emit on their own, like the sun, and the moon's only using the sun's light to shine.
You're so genius.
You don't read books, huh?
I do, but I don't read a lot.
If the moon didn't have the sun to shine on it, no one would see the moon. So no matter if it is day or night, the one that everybody relies on is the sun.
That's true. I'm just like that. Useless.
But the moon is still very important to me. No matter how many stars are in the sky, the moon is still the only one I'm able to see.
I feel the same too. Right now, in my eyes, I only see one very special star.
With so many stars, why do you see only one special star?
Because that star is very bright, very distant, so that I can have one only one to look at.
There is such a star? How come I didn't know?
It's a star that a lot of people like, and out of many some hobbies, I'm just an ordinary person who really likes stars. I don't dare to ask you. I can only secretly ask in my heart.
I have something to confess.
Oh look! It's a shooting star!
To be only yours, I know now. You're my only hope.
I like you too.
Good day, class. Today we will discuss about brightness and colors of the stars.
Previously, we learned that the color of the sun is white. But in addition to white, stars come in different colors such as blue, orange, and red. But how do the stars get their colors? Well, the color of the stars depends on the temperature of its surface. The sun has a surface temperature of about 6,000 kelvins. Red stars like Betelgeuse have a surface temperature of about 3,500 kelvins. And blue stars such as Rigel have a surface temperature of 10,000 kelvins. Cooler stars tend to be red, and once you turn up the heat and make them hotter, they tend to be white or blue. But now, if all of the stars have different colors, why is it that when we look at the night sky, all of them appear to be white? Well, the reason for this is because of our eyes. Our eyes have two sensors that help us see. We have cone cells and rod cells. Cone cells detect color, and rod cells detect shades of gray and motion. Now guess which one of these is most active at night? At nighttime, our eyes rely on our rod cells because there isn't enough light to stimulate the cone cells. So when we look at the stars, we don't see their color, we can only see their brightness. And this is why all of the stars appear to be white in the night sky.
Okay, that's all for today. Oh wait, I forgot to give you our assignment. On page 247, word up, double answer. Okay, that's all.
Goodbye and thank you.
Shan, it's it!
Sorry, Jaya. I can't. I'm in a hurry right now. Sorry, I gotta go.
Dave, save me! Star brightness was first estimated by eye, and the brightest stars in the sky were described as the stars of the magnitude. Hello? Just speaking. What? Okay, I go there.
you're kidding me.
Shan, please believe me.
Oh, I'm sorry. I forgot to say that he lost his memory because of the accident.
No way!
Jea, why are you crying?
Shan had an accident. He lost his memories.
We'll help you, Jea. You're my friend. Seeing you sad makes me sad too.
Ah, I have an idea. Let's help Jea in bringing back Shan's memory.
Sounds great.
On a clear night, away from city lights, the sky is full of stars. More than we could possibly dream of counting, right? Well, if there were a grain of sand for every star that we could see with the naked eye, 9,096. That's it. Every star bright enough to be seen from Earth without the aid of a telescope. Antares is one, +1 to be exact, on the astronomical scale of brightness. The sun checks in at -27, the full moon -13. Even at the darkest places on Earth, like Chile's Atacama Desert, our eyes can only detect objects magnitude 6.5 or brighter. But with bigger eyes, we can see a lot more. This is the Andromeda Galaxy, the nearest major galaxy to the Milky Way, and it's full of stars. Earth is surrounded by 360 degrees of space in every direction. Take an arc of 1 degree and divide it into 60, and that's an arc minute. This 1.5 billion pixel image from the Hubble telescope covers about 1,000 square arc minutes and contains more than 100 million stars. Let's put that into perspective. If it was brighter, this is what Andromeda would look like next to our moon. But we don't have to look at an area of sky that big to find 100 million stars. Let's take a closer look at this little piece of sky. The Hubble telescope was aimed at this sliver of sky. Its shutter opened for 2 million seconds, and from a seemingly empty corner of space emerged not stars, but thousands of galaxies. Some of these are as old as 13.2 billion years. Photons emitted near the beginning of the universe itself. The faintest objects in this image are 10 billion times dimmer than we can see with our own eyes. To cover the entire sky, it would take 30 million squares the size of this Hubble Extreme Deep Field. Scientists estimate that the observable universe contains about 200 billion galaxies. If, instead of stars, we made every grain of sand a galaxy, it would fill 27 cubic meters. So, how many stars are there? Maybe 1 septillion. That's a number that's so big that it doesn't make sense. But one thing we can be sure of, there's not enough beaches on Earth to hold them all. Carl Sagan said that Earth is the shore of the cosmic ocean. So remember, each night when we look up at a sky seemingly filled with stars, we're only dragging a finger through the sand. Stay curious.
develop, they accumulate mass from the clouds around them and grow into what are known as main sequence stars. Main sequence stars, like our own sun, exist in a state of nuclear fusion, during which they will emit energy for billions of years by converting hydrogen to helium.
There in space, there's huge clouds of dust and gas. And if one of those clouds of dust and gas is massive enough, its own gravity causes it to start to collapse. So it falls in on itself, and towards the centre of that cloud, it gets denser and denser, it gets hotter and hotter. And eventually, the particles that the gas and the dust are made of are brought so close together that they start to stick together, they start to fuse. That's the energy source of a star. The star switches on and begins to shine.
Inside every newborn star, hydrogen atoms are fused together to make helium. This process is called fusion, and it creates the energy that powers every star. What happens to a star during the rest of its life depends on how massive it is at its birth.
A star like the Sun is in a delicate balance between gravity, which wants to make the star collapse in on itself, and the pressure that pushes outwards that comes from the energy that's been produced in these fusion reactions happening at its core. However, at some point in the future, the hydrogen runs out. And at that point, the core of the star will start to collapse in on itself under its own weight. It gets denser, it gets hotter, until a point where you can actually start to use the helium atoms themselves as the fuel for the fusion, pushing helium atoms together and making carbon and oxygen the next heavier elements in the periodic table.
As the star begins to fuse helium, it creates more energy, and that causes the outer layers of the star to expand. One day, our sun will grow so large it will swallow up the inner planets of the solar system, out as far as the Earth. It will become a red giant. For the sun, this will be the beginning of the end.
What happens is that the outer layers of the star get farther and farther from the middle. The force of gravity that they feel is getting weaker and weaker. And actually, the star loses hold of its outer atmosphere. Its outer atmosphere drifts off out into space. It expands out to become a planetary nebula. And they're some of the most beautiful objects in the universe.
Once the outer layers have drifted away, all that is left of the star is its core.
A white dwarf star is the dead remnant core of a star like the Sun at the end of its life. What's left behind is something that might weigh as much as half the mass of the Sun, but it's only about the size of the Earth. So it's an incredibly dense object, it's dead, there's no nuclear fusion going on it anymore, it's incredibly hot, but then over millions of years it will gradually cool down to become a black dwarf.
Some stars, however, are much more massive than the Sun, and they lead very different lives. They are able to fuse heavier and heavier elements inside their core. The star gets bigger and bigger. Some grow up to 1,000 times the size of our Sun, until it has fused elements all the way up to iron.
And once we've formed an iron core, there's no more energy can be got from fusion. That core collapses. The rest of the star starts to collapse in after it, but then it bounces off. There's a huge shock wave, and in just a second, bang, the outer parts of the star are blasted off into space in a huge supernova explosion. These supernova explosions are so powerful that when one of these stars explodes, it can actually outshine the whole galaxy of which it's part, a galaxy of maybe 100,000 million stars.
For these supergiant stars, all that is left is the super-dense core, known as a neutron star, an object that can have a mass greater than our Sun, but be less than 20 kilometers across. But for the most massive stars of all, we think when the core collapses, the gravity is so strong, it becomes a black hole, from which not even light can escape.
So stars are actually the places in the universe where the elements are created.
After the Big Bang, our universe contained only hydrogen and helium. All the other heavier elements were therefore fused inside stars.
The amazing thing is that virtually everything you see around you was made inside a star billions of years ago before the Sun and the planets were formed. And when that star died and blasted its guts out into space, that formed the raw materials from which our Sun, the planet Earth, and indeed ourselves were made. And actually, I think that ultimately that's one of the major reasons why I think understanding stars is crucial, because it's actually telling us where we came from.
So, we totally love stars.
Yeah, of course! I wish you remember those memories.
Jaya, I'm so thankful that you helped me for bringing back my memories. So, I'm sorry, but I can't help you.
What? You didn't remember me?
I'm so sorry.
Forget the shot. I'm hurt. I'm deeply hurt. It hurts a lot here.
Jaya, wait!
Listen to miles away from seeing you, but I can see the stars from America. I wonder, do you see them too? So open your eyes and see the way our horizons meet, and all of the lights will lead into the night with me. And I know these scars will bleed, but both of our hearts bleed. All of these stars will guide.
Shan, something bad happened.
What happened?
Jaya, it's hard to explain.
Jaya had a heart attack. She's in the hospital right now in a critical situation.
What? What did you have to say?
Time of death, 3:07 a.m.
Jaya! Jaya! Wake up! Your memories are back!
It's so sad that I lost my mom. She's always looked at me all the time.
It's okay.
No, it's not. It's my fault.
You didn't do anything wrong.
No, it's my fault. Jaya, where did you leave us?
Dali, mag-sip ko sa natin.
Walang forever.
On the radio it beats. They're playing Chasing Cars, and I thought of us. Back to the time you were lying next to me. I looked across and fell in love, and so I took your hand back through lamplit streets, and knew everything led back to you. So can you see the stars over Amsterdam? Hear the song my heart is beating to. So open your eyes and see the way our horizons meet, and all of the lights will lead into the night with see the stars from America.